All right, we're going to get started in a minute, so if people could take their seats, and I'm going to pass out the blue sheets. And if you're sitting in the far back of the room, you are welcome to come up here. It's not like we're out of room.
Sorry.
No worries. So, I don't think we're on video today, but for anyone who is speaking, there is this clever little outline of tape here that's where you're supposed to stand. So just in case someone's watching a video stream here, please do stand in that little box. Can everyone hear okay? All right, good. So we are going to get started here. We have a relatively short meeting today. So I put the blue sheets down. Please make sure you sign them and pass them around. We'll check again later. We have a fairly short meeting today because we asked for 2 sessions instead of one big one. The other session's on Wednesday. When we get into the agenda here in a minute, we'll go into that. We also had, unfortunately, one of our presenters have travel difficulty. I don't know what that meant exactly, but he's not here. So that freed up a little bit of time as well. I'm not going to butcher the person's name. So with that, we'll get started here. So, of course, this is an IETF meeting, which means that all of the conversation in this room is considered a contribution to the IETF. The note well applies. If you haven't read it lately, I encourage you to do so, preferably before bed, something like that. We have blue sheets going around, and unfortunately our secretary is not here today. Sam couldn't make it this time, so I want to say thank you to John and Ignis. Sorry, where is he? Where is he? Our note taker just stepped out. Okay, you guys get little special shiny stars to put on your badge as a thank you. It worked in kindergarten, so why not? We actually are running a WebEx here, so if anyone's having a hard time seeing the screen, it looks fuzzy to me, but it could just be the angle I'm at. I don't know. We're also putting them on WebEx, mostly because we've gotten in the habit of doing that for interim meetings. The agenda. So we'll take a minute to take any feedback on the agenda if anyone has anything that they would like to add. This is the agenda for today. As you can see, there's a couple of slots missing. Like I said, we had a presenter who was unable to make it. So that actually freed up about 30 minutes of agenda time. So in one possibility here, we'll get out a little early, which would not be the end of the world. But it also means we have a little extra time to talk about some things. So we'll use it if we need to. This is the agenda for today. We have, like I said, another slot on Wednesday with roughly the same amount of time in the agenda. Before I move on, does anyone have any agenda bashing to do? And I'm happy to see nothing. So briefly, before we get into the presentations we have scheduled here, we want to give a quick status discussion. And this isn't just the sort of, chairs kind of throwing up some slides and then moving on. We actually would like to get some feedback on some things. So please pay attention. So we've had a number of interim meetings, and I think that they've been productive, that it's been helpful to furthering the conversation. We've had some focus on particular topics at those meetings, which I think has been a good idea. One thing that is a little difficult is that, we're supposed to take minutes and blue sheets at those meetings just like we do here. And the blue sheets aren't exactly normal. Here there's literally a clipboard with a blue sheet on it. So we've been trying to do something in the interim meetings, which is to have an Etherpad page where everyone can go type in their own name. And I feel like it's working okay, except that we're roughly getting maybe half of the people actually putting their names on it. I guess I'm in part asking for feedback. Does anyone think that's a horrible idea or a good idea? I see a thumbs up, so that's a good thing. Good idea. So that's good feedback. If someone disagrees, please say so. I would encourage people, when we have these interim meetings, to please make sure that you go fill out the blue sheet. Try to use the mic, sorry. Do we only have one mic?
Hi, Tom Herbert. So don't we already have all the attendees on the WebEx information?
That's actually a great question. So we tried at one of the earlier interim meetings to take screenshots of that little attendee list, and it was actually awkward because people kept coming and going at different times in the meeting. So we reconciled like 3 different screenshots to get the full list of names. And some people complained actually that that's not the way we take names for blue sheets. So if you're in the back of the room and you don't want to fill out the blue sheet, technically you're supposed to fill it out, but we can't force you to fill it out. So make of that what you will. We decided to maintain the same kind of voluntary process, and it might be nice if we could get a report that said at the end of a WebEx, here's everybody who was there. Of course, that assumes that they use real names, et cetera, et cetera. So yeah, we're back to an Etherpad approach. So in any case, I know it's probably not a big deal to most of you because you show up at the meeting and you participate as you want. But as chairs, we have a responsibility to make sure that those names get taken. So please do try to help us out with that as much as you can. So milestones. So we had a good discussion about requirements milestones here, and a result of that, you'll see them on the screen in blue, kind of highlighted in blue. As a result of that discussion, we changed the milestone date to line up with the solutions milestone dates, which are there in green. The purpose of that was really to recognize that we actually don't care so much about producing requirements by themselves. Obviously, requirements are helpful when it comes to producing solutions, but we really want to produce solutions. So by moving them all together, the anticipation is that we'll produce them all as RFCs basically at the same time. And of course, there's some details around that. We might treat some of them differently depending on whether there are multiple documents versus we can merge them in one, et cetera. There's another question, the items that are in that sort of dark red, the current milestones for those are due next month. When I say next month, I mean, in a handful of weeks. So we have to decide what we're going to do about that. I've got a slide in a minute to revisit that topic, so we'll get into more depth there. We actually have time to talk about it here, so I'd like to do that if possible. So jumping through some document status, and this is where we'll touch on those milestones. Of course, we have a couple of RFCs published. We don't have anything in the editor's queue. And these are the 2 drafts that I referred to in the previous milestone slide, the architecture and the use case draft. So I'd kind of like some feedback on this. What I'm thinking, and Matthew and I have gone back and forth on this, and we recognize pros and cons to either approach here. But what I'm thinking is that we want to get these documents to the point that we're comfortable with them like we would be after a last call. Now that can either mean that we then publish them as RFCs and continue on with our work, or we can put them in it's just sort of a informal state of being pending solution work so that we can update them if necessary as solutions come along. Now, one of the downsides to that second approach is that we don't actually have something set in, a stake in the ground around which to make decisions about solutions. That would be unfortunate. On the other hand, it means we don't have to produce new versions of those documents if they need to change later. So again, pros and cons on both. Matthew and I have gone back and forth, and I think right now we're sort of leaning toward publishing them sooner than later and then revising them if necessary. But it's kind of, from our point of view, it's kind of arbitrary. The point is to get the good work done in solutions. So before I move on to the other document status, I'd actually like to get feedback from everybody here. Does one approach or the other seem like a good idea, bad idea? Do you not care at all? The documents are where they are, and we want to have discussion about them either way.
So the Ashish here.
Make sure the mic's on. I'm not sure.
Oh. I'm not sure if this mic has a button.
Yeah, this is a wireless mic too, so we'll adapt. Actually, I wonder if any of these work.
Ashish here. I suggest going with the first method and making it into an RFC. If we keep the requirements and use cases in a constant state of flux, that does not give a solid foundation for the solutions team. You'd much rather have a set number of use cases first that are defined and then make solutions for them. And if new use cases come up, have an errata and have different solutions address the new use cases.
Okay. Yeah.
So can we maybe just do a show of hands to see who's read these two drafts? So for the architecture draft, can you just raise your hand if you've read the latest version? Okay, that's quite good. And now for the use cases draft. There's a few less, but still some. Yeah. Okay, thanks.
Were there other comments? I think a couple of people came to the mic. I don't know if you wanted to say something about this. I don't know if the mic's working, but. Yeah, this is fine if you have a comment. And if someone can maybe help me out and see if we can get that mic working. Thanks. Go ahead.
Osama. So we don't have to treat both of them, I think, the same way. So I think architecture needs to be RFC'd, but I think for use cases it will be beneficial to, delay it a bit more.
Okay.
Hello? Yeah, I think I disagree. I think both drafts should be ahead to RFC sooner rather than late.
Larry Krieger, Cisco. So I guess I have mixed feelings. On the one hand, I feel like the architecture has been out there for a long time. If there were significant things to change, then it should have come up by now, so we might as well just go ahead and RFC. If it hasn't changed now, it's unlikely it's going to change. The argument for keeping it open was that solutions, when they came, would come up with a different way of doing the architecture, and then we would say, oh, now we published it, we need to take it back. But I think I'm leaning towards, unless soon someone comes up with something big to change, that we should just go ahead and RFC.
This is Mehmet Toy from Comcast. I think it should be RFC. I don't see any reason not to.
So maybe what to think about is doing a slightly longer last call than usual, maybe 4 weeks or something, to give people plenty of time to review it in detail and have a good think about whether they think there's any solutions that are going to come up that would contravene it or would need extensions straight away.
All right. We'll send we'll send a mailing list message on this topic before we do anything to hear any other feedback that might not be in the room right now. But it sounds like we're kind of converging around a way of approaching it here. So we'll follow up on the mailing list, and I appreciate the feedback. Continuing with the document status, we have, as I mentioned before, a number of requirements drafts that we are going to kind of hold back until solutions come out. They don't literally have to be published at the same time, but we want to see them progressing with each other in some way. That doesn't mean that we lack confidence in these documents. It actually, in my mind, has more to do with how we might end up publishing them, because we may actually want to merge the requirements into the solutions documents in some cases. So please treat these as being key to the work here. The data plane requirements draft we actually need an editor for. So not right now, but perhaps after the meeting or whenever you're comfortable doing it. If you could let us know if you're interested in editing it. We need to pick somebody who can kind of help own it editorially more so than technically to get it done. The NVE, NVA control plane requirements, I think, are in good shape right now. We'll probably open up some discussion on that at the appropriate time. There's a presentation today on the what is sort of labeled the hypervisor to NVE draft. The name is perhaps a little too specific, but whatever. One question that I want to ask, and since there is a presentation on this later, we can actually talk more explicitly about it then. But the draft refers to BDP as a potential protocol for the solution in this space. In particular, so VDP is an IEEE protocol, and in particular there would be some extensions to it that would come to, let's say, to the IEEE as requirements from NVO3, and you might imagine then that NVO3 specifies that protocol as the solution to the space. So in order for that to happen, there's this kind of limbo that we go through where we would send a liaison to them telling them that we're interested in the work, here's the requirements, and that we'll monitor it, and then later on perhaps doing a consensus call as to whether that actually solves the problem for us. And we would kind of iterate through that appropriately. So what we're thinking is that we would send a liaison message to the IEEE with that content and go from there. But I wanted to make sure that everyone understood that process, and if there's any questions, please feel free to ask now. And it seems fairly straightforward, I think. The security requirements draft is on the agenda, or I'm sorry, it was on the agenda, but I think that's one of the presentations that our speaker couldn't make it for. I reviewed it very recently, and I think it's actually in very good shape. And frankly, because there's not a specific solution that might be published for this, it's the one example of a requirements draft that we might decide to promote to submit to the IESG sooner than the others. So I'm looking at it as being fairly close to done. And of course, we'll send a last call to the mailing list before we do anything like that. But if you haven't had a chance to review it, please do. There might be one question in there around underlay-overlay relationships with regard to OAM. So if anybody has, when we talk about the OAM topic on Wednesday, if anybody has thoughts on how the security model applies there, it might be valuable to bring up. So as you know, moving on to the fourth document status slide, we are in the midst of a poll for adoption of data planes, the VXLAN GPE, GU, and Genève. And so far it seems to be sort of uncontroversial, and everyone seems to support the adoption of these. So that should be a simple process. I think we wrap up in a week, maybe a little more than a week, something like that. So please read and have a look at them. There was some good work done by the routing NCAP design team. I can't remember if that's the right title or not, if it's NCAP DT or DT NCAP. But in any case, that draft has some very good considerations. On the previous slide, when I talked about the data plane requirements, we need an editor for that document. One of the things we'd like to see happen is that they may actually be perfectly in line with one another already, but I'd like someone to evaluate that a little more carefully and make sure that the data plane requirements for NVO3, they're certainly more specific than the routing NCAP requirements that this document refers to, but I'd like to make sure that they're in sync with each other. And then our last document status slide, we have not sent messages to the mailing list about these two drafts yet, so I wanted to give the room an opportunity to comment. The first one is a multicast framework draft. It's been presented at one or two interim meetings, and the latest version, I think, takes in the feedback that was received in those meetings, talks about mechanisms for distributing multicast traffic, and then some of the sort of, I'll call them proxy functions that you may need in order to facilitate that. It is somewhat architectural. It's not a solution. It's not requirements. It's a discussion about how to achieve this goal. So one of the questions that we have as chairs is whether it should be published as its own draft or tried to merge into the architecture. I don't have a strong opinion about that. I suspect that simply publishing it would be the most straightforward route. So I'd like some feedback on that. If people agree, then we would send a call for adoption. But I don't want to do a call for adoption and then try to force some kind of merger if that was the best choice from the beginning. Does anyone have feedback on that right now? I see some confused looks, but maybe it's just Larry.
Okay, since you called out my confused look, if I recall, the second one there, the Sarakaya draft, is specifically using DHCP to get the multicast, which is not, it's very solution oriented, right? And the first one is more architectural, as you mentioned. So I was looking confused because I thought you were talking about merging these two documents. Is that?
No, I'm sorry.
Okay.
Yeah, you misunderstood and/or I misspoke. I was referring to just the first document, the multicast framework draft, and I was referring to the possibility of merging its content into the NVO3 architecture draft.
Okay.
That's one possibility. The other is that we adopt it and publish it alongside the architecture, basically. And like I said, I don't see really a strong advantage or disadvantage to either approach, except that it might be easier to, it's already written, to adopt it. I haven't actually talked about the second one yet on this page.
Okay, now I have opinion on the earlier question you had about architecture documents stay open. And I think it should be closed, like all other working groups in IETF. We have architecture documents, we have use case documents, become an RFC, get and move forward. Because I can see this kept going, like now we have a multicast. Maybe a year down the road we have something else. And this architecture will become really hard to accommodate all those things. It has happened in every working group here. We have architecture document, we had different approach to tackle different problems. Make each document a little small, easier to read. I don't know about you. If I have a 70-page document, I get those off. But you have focused document, people read it, understand it, can move forward.
Yeah, I think we hear that concern.
And share it.
Anup Ganwani, Dell. I don't know that I have much more to add than Linda, but I
speak a little closer. I'm sorry.
I don't know that I have much more to add than Linda, and it's Anup Ganwani again from Dell. But yeah, I just wanted to reiterate the same thing, that it's probably better to have a smaller focused document and move that ahead on its own. Thanks.
Thank you. That was good feedback. The second document on this page is complicated for a different reason. So this draft refers to a mechanism based on DHCP around which an NVE, but specifically a VTEP, a VXLAN NVE, would use DHCP to basically be assigned multicast group addresses for the underlay, if I understand it correctly, based on the VN. It's a fairly straightforward mechanism, at least I think so. I'm no DHCP expert. So technically, it seems like a pretty simple thing to address, to adopt and deal with. However, it doesn't seem to satisfy the whole architecture of NVO3. So if we were to adopt it, it would not be in lieu of other control plane work. It would be perhaps as an addition to that work, either as part of a bigger suite or just something on the side. So if you haven't read it, I would actually appreciate that you do, because my inclination is to adopt it, but since that doesn't have a really clean kind of fit into the overall work stream that we've got here, I want to make sure that we understand what we're doing beforehand. If you have comments on it now, I'm happy to take them, but otherwise, like I said, just encourage you to read it and comment on the list.
Anup Ganwani from Dell. I'll just say the same thing that I said at the interim meeting, which is that it really doesn't fit in with what we're trying to do here, right? Which is centralized control plane. You can get all the information that you need from a centralized control plane. So, but then again, if this work were to be done, the question is which working group, because it doesn't look like it belongs in this group.
And what you just said is actually the concern that would lead me to think adoption makes sense, because if we don't adopt it here, it's not clear where the work might happen. The DHCP, DHC working group perhaps could, certainly they have the expertise on the DHCP side of things.
Exactly, yeah.
So maybe there's another approach. I don't know. Right. We can talk to the ADs as well. I agree with your point, though. It would not be in lieu of the larger work plan we have here.
Right. Okay, thanks.
Thank you.
this is Bachir Sarikaya. Yeah, I'm the first author of this draft. As Benson said, we would like to see this adopted. And regarding the DHCP, yeah, we talked to the DHCP chairs, and they really reviewed this draft, and we handled all their concerns. At least we think so. But they don't want this to be discussed in the DHCP unless we adopt this here. Then I'll ask a slot in the DHCP, so we'll present it there. Then I think that's how they prefer it. It's kind of application for them. That draft should be handled outside of DHCP.
Okay.
Thank you.
That's good. So we'll follow up. We can follow up with the DHC chairs and the ADs and so on. We'll figure it out. So yeah. Anyway, please do read it. Like I said, I think it's straightforward, but maybe I'm missing something. With that, we can move on to our first presentation, but maybe before I do, just any last comments on the things we've talked about here? And silence is golden. So who is next here? Tom. And Tom, I have a little clicker thing you can use. Tom, I think he's getting it in the back. I hate to ask, can you stay in the box? Yeah. Apparently people on the video streams were like walking in and out of frame all the time, and so they put these boxes here. Yeah. Okay, can you hear me now? Here. You can make this work.
Hello? Oh, it's much better. Hi, my name's Tom Herbert, and today I want to talk about identifier locator addressing. So this is another data plane solution for network virtualization, but it is kind of motivated by something that we see in the data center, which I'm going to call task virtualization. But this could also be applied to a general VM case, which I'll talk a little bit about. So task virtualization is a concept that we have a data center running many tasks for many jobs, basically how data center works. I have an example of this. And what we really want is the ability to be able to move tasks between machines in kind of an arbitrary fashion. And the networking component of this will be that we can move addresses and network connections with these, not virtual machines, but actually tasks. So if we consider kind of the canonical topology of a data center, it's obviously a very scaled down model. What we typically have are racks with host, and host have a top of rack switch, connects to a fabric, and we build out data centers in this model with many racks, many switches, and what have you. So what we usually have in a large data center is a job scheduler. And the role of the job scheduler is to schedule the different tasks for different jobs. So if you can imagine, say a company like Google has jobs for Gmail, Google Maps, search, what have you. And what we need to do in the data center is schedule the tasks for these jobs in order to meet the resource requirements of the jobs. So one thing I would mention is there's not a lot of homogeneous resources in a typical data center. We have kind of mixes of hardware and networking capabilities. So it's often a problem with the scheduler is how do I schedule optimally to satisfy the resource requirements of the things I'm scheduling. So in this case, we have the scheduler, and the different colors represent the different jobs, and then within the jobs, we can schedule multiple tasks. So we get into scheduling dilemmas pretty quickly. And this is the case where we want to schedule across a data center with very high utilization, but then we have a problem when something more important comes along, more important tasks, what do we do? And unfortunately, the current solution kind of is that we have to kill existing tasks and make room for new ones. So in this case, the purple guy comes along, and we have to zap three running tasks because it's more important that this runs, and resource constraints mean it has to run on this rack. So this is obviously very unpleasant. The result of this is that we lose all the work that those tasks had done. Typically, we would have to restart those on a different rack and kind of pick up the work. It does make scheduling a nightmare in the sense that this distributed job schedule has to put a lot of effort into trying to optimize on the first pass. If it doesn't do things right and has to rearrange a lot of work, then we lose a lot of work and kind of kill the utilization in the data center. So what we really want is the ability to do task migration. And again, this would be under the auspices of the job scheduler. So it would figure out that the appropriate place to run these new tasks are on this rack or on these hosts. And there's existing tasks, but if I could just move those to another place where it's acceptable they run, then what I eventually get is a new partitioning of the resources. I've been able to satisfy all the resources or all the task resources, and life moves forward. So that's kind of the goal. And of course we want this to be sort of transparent to everybody, so we don't want applications to have to worry about this. We could, for instance, ask them to do checkpointing and things like that, but it's obviously pretty invasive. One important thing though is this is really trying to... Okay. Wow, that's really strong. I'll hold it like this. Thank you. So, zero performance impact when not migrating. So again, this is not a new green field where we're bringing in VMs, creating new products. This is actually trying to transition the existing data center, how we run these jobs, into this new model where we're just adding this capability that we can move things around kind of seamlessly. And in addition, security and control, these should just be straightforward, continue to work as they already are. It's important to mention this is more containerization than VMs probably. We don't particularly need overlay networks or virtual switches in this model, so that's kind of where we depart from VMs also. We do expect, though, that everything that currently works in this new model. So in particular, ECMP, the network offloads, things like that continue to work. It's also an interesting characteristic to point out that most tasks we create probably won't be migrated anyway. The expense of task migration isn't just in moving the network addresses, probably more expensive to move the memory and the storage along with it. So we want the capability, but we don't expect to use it too often, so we can probably limit that to some extent. So the solution in ILA goes back to kind of an ILNP model where we can take an IPv6 address, split it into a locator identifier. So in this case, though, the identifier will be an identifier for each task. So we're going to use a unique 64-bit number to identify tasks that become the identifier. And we'll have the normal mapping of identifiers to locators. If a task migrates, its locator changes, its identifier stays the same. And when not migrating, as I mentioned, the data path should be identical to what we have today. So again, zero performance impact. So the address split, like I said, this is modeled very similarly to ILNP. Locator, top 64 bits, identifier, bottom 64 bits. The locator will identify physical hosts in the network, so all of the switches and routers will basically be routing on the top 64 bits, and it's routable. This will not be used in a connection endpoint. Identifier, again, is kind of the virtual address for the task. Not routable. We can use that as connection endpoint. One thing we did add that really wasn't in ILNP is a type. We'll use that type to encode virtual network identifiers and some other information if necessary. So we also have the ability to use this with kind of the more canonical virtual network virtualization. And in this case, we can embed a virtual network identifier into an IPv6 address. So in this model, we'll use some of the bits in the identifier to be the virtual network identifier, and then some of the bits to be the virtual address. So in the case of IPv4, this works out really well because we can actually put the full virtual IPv4 address in the vAddr, and the virtual network identifier we have 24, or in this case would be 29 bits of virtual network identifier. So this actually would be a great solution in a sense. It would accomplish the same thing that VXLAN or NVGRE does. But we do run into a problem. This doesn't include any extensibility. So we're using IPv6 as IPv6. There's no encapsulation, which means we wouldn't have any space for security, for instance. So that's kind of why it's not a general purpose solution for network virtualization. But it would also allow us to do some things, even in the VM case, that we found kind of difficult. One thing, if you can imagine, in a data center, we may have a server that is running as a common service across many different tenants or virtual networks. And we want that connectivity to that server from each virtual network. So I guess the common solution probably is to use a lot of NAT, basically from a VM, NAT into a server's, using in the VM's address space, one address, and then NAT into a public address space. In this case, it actually might be a little simpler because now we can just use an identifier of the service and actually map that directly. So it probably gets us out of using stateful NAT in that case. And similarly, this also could allow us to have two VMs and two different virtual networks to communicate with each other. So again, in those two cases, there's no security as part of the encapsulation like we would get with something like GU. But the advantage is this allows us to communicate from within a VM virtual network outside of it using a kind of a common address format. So there are a few details to this. One is we need the identifier to locator mapping. And I'm presuming this is pretty much the same problem as virtual address to the physical address sort of mapping that the NVO3 control plane will provide. So I'm hoping the NVO3 control plane just gives us this answer. We also need to represent these addresses in a user-visible way. So we'll be putting something in DNS, for instance, that will indicate an identifier, and then we can connect to that from the user space. And at some point, locator will be attached to that in order to send it. And then one interesting problem actually is how do you create identifiers across a whole large network that are unique for each task? And there were a few examples of this in some of the RFCs with this, but we actually found 64 bits. We may be able to use some sort of timestamp-based identifier creation method to get some unique identifiers. So the identifiers kind of have to be unique across the whole network for this to actually work. Question?
Yes, sorry. Sharon, the very Broadcom. Is this IP address visible to the core of the data center?
The IPv6 address, the fully formed address is the locator plus the identifier.
Yeah, this doesn't
That's
work.
what's set on the wire.
This won't work because now you require us to do exact match lookup for this address. We cannot do longest prefix match anymore.
No, the only thing the core has to look at is the high order 64 bits. The high order 64 bits will address the physical host. So assuming we can get like a /48 or lower from allocation, then we can give each host its own 64-bit address, and then the lower 64 bits are within that host.
So you cannot do mix and match. All the data center must be upgraded to this.
I think you can mix and match. It's a matter of the address. So if I say this 64-bit address has this route, that's all that the data center, the fabric needs to know. The fact that it goes to a physical host should be kind of less important in some sense. So mixing and matching is important. We have to be able to allow that, obviously. We can't take over the whole data center address allocation because of this.
Yeah, one more question I have. What is the difference between this and Lisp? Why didn't use Lisp?
So Lisp, I believe, is an encapsulation. So it does locator identifier, but adds an encapsulation header.
Yes.
In this case, there's no encapsulation. So the packets on the wire would look like a IP over, or TCP over IP, UDP over IP. They look just like the packets that we send today. And in fact, that's important because all of the network mechanisms, ECMP, what have you, will still be using that. So we want to make this virtualization without encapsulation in order to remain compatible with the rest of the network. It does kind of entail significant use of NAT, as you can imagine, but we think there's ways to kind of mitigate the impacts of that.
This is Linda. So I didn't hear clearly, like if two hosts need to communicate with each other, right? Is it not working anymore? Hello?
You're good.
Okay.
Speak up a little.
Okay. So if A need to talk to B, and B used to be on this location, now I moved to a different location. So A has to be informed, now the address is different. So how do they know that this one is no longer this address anymore?
So B's identifier is constant.
B's
So
identifier
when B moves, it moves to a different host. Its locator now changes.
Yes.
So the locator needs to go back to A. So this is where the mapping distribution, and I believe it's the same thing with the canonical NVO3. There's a mapping between identifier to locators. And when that mapping changes, then the senders need to be updated.
Okay, then, so in NVO3, we suppose there's a virtual switch on the host to make these changes. The guest OS is still A is A talking to B. They are not seeing any network.
So yeah, this all would be transparent to any guest OS. So this would be, if you think of it this way, at the encapsulation layer today, we would, instead of doing an encapsulation where we put in the physical host address in the outer header, we're just putting kind of the physical host address into the packet or the destination address itself. So it's the same operation except without encapsulation.
Okay, thank you.
That makes sense?
Okay.
This is Dino. Test. This is Dino. Why don't you just use ILMP and make the changes you want to the ID field, and you could use all those protocols, and because it's been around for a while and it's been tested.
ILNP?
Yeah.
So ILNP is very interesting, and in fact, we're talking with Salim on it.
Okay.
The reason is, one, the control plane. They kind of have their own control plane, and this is much more like an NVO3, where we want that centralized control plane to do distribution. And then the second reason is
So
in ILNP.
You think the mapping database that NVO3 is going to build will be more appropriate for your application than what ILMP did?
Yes, it's the same. It's logically the same.
Okay.
Right. It's a mapping of physical or virtual to physical addresses somehow. So I believe that's kind of the same thing. Most of ILNP is kind of already mirrored here, and we're doing the 64-bit split, which makes sense. So we'll leverage as much as we can out of that. I think the parts where they're using DNS to convey some of the locator information probably is not as interesting here. I'd rather use the centralized control plane for NVO3. That's why I think it's appropriate in NVO3 for this.
Bob Moskowitz, HT Consulting. So there's no binding between the locator and an identifier that you're doing here. There's no binding. So you have to have some method that I'm now moved over here, and you can trust that I really am over here, and this is my new address where you will find me. Is there any notification of the partners that's currently talking to in the move, or is there a discovery process which comes to the fact that it's moved to a new address?
I think that is part of the control plane. So also remember that the movement and the scheduling of this is being done by a centralized job scheduler to begin with. So the orchestration can definitely happen from that level. So it's not clear to me that a host has to tell the rest of the world where it's located, or if that could be done by the central control plane. I think the latter model is actually will be a little more secure, as you point out. Do we want to trust somebody to say where they're at, as opposed to being told by a central authority where they're at? I think that the latter is probably a little cleaner model for this.
Because we've seen in so many mobility cases how everything breaks. You know, your communication breaks because it's no longer at the address you thought it was at that you've been talking to all this time. Now all of a sudden it's someplace else. So now you have to restart your sessions because of the move.
So I think from that point of view, I'm just going to fall back on saying there's isomorphism here with what we need for ILA with the NVO3 control plane for any other encapsulation protocol. So if we accept that migration, we want to do live migration where we don't drop connections, then yes, you need a control plane or some mechanism that says or tells the senders, okay, the locator or the identifier or the virtual address for this host you're talking to has moved, please update, and then update all of your tables.
And that's in the documentation. I will find this discussion.
Excuse me?
And I will find this discussion in your documentation on this.
Yes.
Okay.
Sound dubious, but okay.
Hi, Diego Garcia del Rio, Nuage Networks. So one question there. So the host, well, the processes themselves, would they be filling in a random or a well-known location that then gets overridden by the vSwitch or the redirection process? Because, I mean, a v6 packet is still coming out of the virtualized process.
Right. So the way to think about this is that from the task, we use IPv6 to connect. So we'll get some sort of IPv6 address that doesn't have a locator, but we'll know that. So it'll be like some default prefix with an identifier. So that's what we have in DNS. So a task will get that, send a packet addressing to that, and then somewhere at a lower layer, we need to overwrite that kind of default prefix with the actual locator. Okay. That turns out to be, I believe, a stateless NAT sort of operation. So, for instance, we'd have to update the IPv6 or the UDP and TCP checksum if they were present. So in real implementation, though, because we know we're doing this, we want to consolidate all that and hopefully not have to do any rewriting of checksums, anything like that. So we'll probably squash that into a single operation. So it looks a lot like a routing, packet routing in a sense. So like I kind of think this is like ARP resolution, where we are writing the address as part of sending the packet. So somewhere in the data path, all that would be kind of contained.
Okay. But it still means you're still routing /64s all over your data center, though.
Yes.
Okay.
And Tom and Sharon, we're running a little hot on time, so maybe let's just ask the question and keep going.
Yes, Sharon from ContextStream. So this is another form of encapsulation, really. I mean, let's be practical. It's completely equivalent to VXLAN minus some bits. So I don't want to argue about the merits of having GU and VXLAN and NVGRE and a bunch of others. That's not the point. The problem I see is that this is an absolute overlay, and I see already confusion in the market by customers having data centers in data path and thinking that IPv6 solves their problem. And in fact, nothing is solved by this format. You still have to do all the mapping, consistency, aging, authentication, everything that you have to do in overlays. So it's very clear, it's very important that this is made clear when you communicate this idea, which is not bad, but it's one more encapsulation.
So I guess encapsulation is a broad meaning. When I say there's no encapsulation, I mean there's no explicit encapsulation header.
You encapsulate and then you mangle it. Okay. No other problem is solved. So de facto it is another encapsulation.
So the overhead for this is...
I don't care about the overheads. It's exactly equivalent.
Well,
right?
But the overhead is important to me because, as I mentioned, we are trying to replace an existing data center with a capability. So I don't want to add any of the overhead normally associated with encapsulation. I want things to work just like they do today. So no overlays, no virtual switches. If I can get rid of all of that, I just have what looks like the same network that I have today, only adding this new capability.
Okay, so that statement is misleading because when we discuss overlays, okay, there is this track which examines all the various encapsulations, and this is one of them. you want to do it in INV6, you want to do it in Bloom filters, you want to do it with VXLAN, whatever you choose, each one has advantages. More bits, less bits, okay. But that's only a fraction of the problem of creating overlay networks. The biggest problem is conveying global information. DNS, just saying DNS is not an answer, as we know. So the discussion must be a lot clearer about this idea and in the context of encapsulations. That's what I'm saying. Otherwise, I already see the confusion.
Okay.
Yeah, Eric Nordmark, is this on? The mics are tuned differently. So clarifying question. I'm assuming that the host, the guest VM, whatever, will go do a DNS lookup and get back 128 bits. Right?
Yes, correct.
And
Quad A.
You're not assuming that it's going to change whatever bits it's using, but instead the actual NVE will actually rewrite the locator as the host moves, and it gets stuff from the centralized control plane. Is that the assumption?
Mm-hmm.
Okay. So, yeah, there is a question about, does that work with IPsec? Are there cases when we basically cover those, so we have a pseudo-header checksum on those bits, right? And you need to change that, because some of the ILMP proposal I thought was advocating, at some point in time at least, that you only want to checksum the lower 64 bits, etc., to make sure that, and only use the lower 64 bits in the host identification, sort of TCP connection identification, to ensure that as you change your source address, which is these 128 bits, it will still match the same TCP connection at the other end. So those imply host changes as far as I know.
So I think you combine two things there. So IPsec or how the host perceives these addresses.
Yes, and both of them are questions, and it wasn't clear to me whether you're
So I'll defer on IPsec. There is certainly a lot of words in the ILMP about that, which I think is useful. The checksum definitely is something to consider. We have to have the checksum work as it does today. So on the wire, a TCP checksum has to cover the same pseudo header, so we can't change TCP checksum, which means at the host we have to rectify the checksum somehow. And if that requires doing a checksum modification, then we could. But like I said, I think in the end, in an implementation, actually just squash that and somehow figure out a way to obviate the need to do any checksum update.
If the NVE is co-located with a host, meaning that it's on the same server, yes.
But that was my model here, right? So this is replacing existing tasks. So yes, if you go that route, then you would need to do some sort of checksum update if the NVE was not co-located.
But it might be that, yeah. Did you look at the connection identification? I don't remember what ILMP said there, but I thought they had done the 64-bit connection ID as well, but as opposed to 128-bit.
But then you would have to change the host. So
Yes,
I'll look into that, but I don't think we could do that.
ILMP did change the host, right, as far as I know.
So we will be changing the host, that's guaranteed, but...
Sorry. Host meaning guest VM, whatever, right?
So
because it's the one that actually has the connection identification. Right?
All right. So you'll have to see the implementation on that.
This is Dino. Eric, remember GSE? GSE was always supposed to do the checksum on the lower 64 bits, and the locator was always 0. So when you went back to the side on the other host, you would return it back to 0, so the checksums would be equivalent. I think he has asymmetric communication here.
So we are actually running over time. So Vina, last comment. No more people in the queue.
Vina Ermagon, Cisco.
Pull the mic a little closer. Sorry.
One clarifying question. You mentioned one of the differences between this and an overlay is that you can run ECMP and other protocols on the upper 64 bits or on the IPv6 address as it is today. Is there any reason you think in the case of an overlay you can't run those protocols like ECMP on the outer header addresses? So how is that different?
Can you repeat the last part?
So running ECMP and other protocols, in this case, it will be on the entire IPv6 address. In the case of overlays, it will be on the outer header addresses, right? But still, you can run it, and the behavior would be similar, correct?
So it's IPv6 is the only header, right? So whatever you can do with IPv6 in the network should just work with this model.
The same for outer headers of an overlay. So outer addresses of an if
Right.
you're using overlays, the same applies to that, right? There is IPv6. If it's an IPv6 overlay, you'll have an IPv6 address, and ECMP will still run on that, right?
So that is a plan. So we definitely want in the encapsulation case where we're using an additional header, make sure that the outer headers actually deal with ECMP or allow for ECMP. So that's why, for instance, in the case of doing UDP encapsulation, the source port would be set to some sort of entropy representing the inner flow. So we get the same effect, but it's still not quite the same. In this case, the outer header is the only header, so the actual four tuple for TCP connection would be kind of represented by that.
Thank you.
Okay. Well,
yeah, sorry, I've
thank you.
jumped to the next slides, but we'll continue this discussion on the mailing list. Thanks, Tom. You can give the clicker to Linda.
Okay. Thank you. Oh, wow, so loud. Okay, so I'll get started. And okay, so this is about the mechanism for NVA to distribute the mapping entries to the NVE. This particular draft has been discussed in the interims twice, and we got lots of comments. And so today I'm not going to repeat what we presented at interim. So for the people who didn't come to the interim, that would be your loss. So maybe remember next time you have to come to the interim. So just in a nutshell, so the distribution, we allow two mechanisms. One is the push and another one is pull. And since the pull mechanism has been much mature, like Lisp is using pull and much mature, the document itself focuses a lot on the push, especially incremental push, right? Every time you get one change, how do you incrementally update to the NVE? And that's also the area we got lots of comments. And so today I'm only going to address some of the new changes since the last interim. So basically, for the push mechanism, NVE has to announce to the NVA that the number of VNs it supports. It happens whenever the NVE goes through a restart or new NVE comes up, any kind of change cause NVE lost connection with NVA. You need to do a VN scoped announcement indicating what VNs he's supporting, so that NVA can send NVE scoped mapping to the NVE. And we are suggesting using ISI's protocol simply because we want to utilize the CSMP mechanism to do the incremental update. The mechanism is already there and is mature, has been deployed, so I think this is very easy to piggyback TLV. So the new TLV we piggyback into is the router capability TLV. We add a sub TLV to indicate the VNs. So during the interim, the comments coming up with how do we represent the list of VNs. Because we can have 24 bits in the future, actually we have 32 bits to represent VNs. The number of VNs each to be represented can be very hard to express. So for that reason, we created 3 different ways for NVE to express the supported of the VNs, the VNs that NVE is participating. So one way, the first way is is a bitmap. Say suppose that the range of VN supported by NVE is not very large, and you can give the starting VN and the bitmap of the VN supported. So that's the first sub TLV added to the routing capability TLV. Second one is supposedly if the network is designed very well, and every NVE has a very nice range of VNs to support. So that's the best case, is basically starting and ending. That's the easiest, best sub-tier we can support. The third one is suppose if you have a simple virtual switch based NVE, the number of VNs you support is very limited. So we can simply just express the list of VNs. So that's the last one. So with that, and that's the end. And the next step is we wish this to be adopted by the working group. Okay, any questions, comments? I know there's one comment sent on the mailing list this week. I haven't got a chance to address them yet.
Anup Ganwani from Dell. I'm not sure how this gets resolved, but I think this is one area where open source is stepping on, or open source and standards are stepping on each other, because there already is stuff out there in open source that you can use for doing much of this.
Is it for distributing the mapping mechanism? All of it? Okay, that would be great if we can look at that and make sure everything here is, whatever they implement can be covered here. Thank you.
So we should have some discussion on the mailing list about this, and we'll chat briefly after the meeting here.
Okay. Thank you.
Tom, is that a question or?
So it might be more.
It's on. You just have to be very direct to it.
Okay. It's good. So I was wondering though. So this is one tangible proposal. Do we expect to have more? I guess OpenFlow would be interesting, but I'm not sure there's an actual draft on how we would do that. What do you think the plan is here?
So yes, I think there will be more, but there hasn't been yet. So I have some questions about how this fits the architecture in a centralized model, but it may not be something that is easily talked about in a large group, maybe email and some whiteboarding. So I don't know the answer to your question.
That was a requirement, though, that it's a centralized model to begin with.
Yeah, to be part of NVO3 framework. But I may not understand the full scope of this either. So.
Yeah, so Eric, not Mike. So I think ISIS can be used to do distributed implementation as well, right? And it's not clear whether this is only doing centralized, because some of these things, I would imagine that in a centralized model, it's actually a central controller that sends out whatever it is. Here's a bunch of ISIS, LSAs, whatever, that says, oh, you should have these VNI IDs, and by the way, you should have these MAC addresses, whatever, because I'm central and I know everything, right? The way it's described here, it sounds more like being capable of doing distributed, when an NVE itself says, by the way, I have these MAC addresses and I want to be part of these VNI IDs, right? And that's, maybe I'm confused about.
Okay, so there are two things. We assume NVA is the authoritative entity which has the information, how he distributed to the NVE. So that's the general
but
assumption.
Would only the NVA originate LSAs then?
Well, in this particular draft, yes. And what you are saying that NVE can report what they have, that's a different aspect. So when we say distributed or centralized, there are two things. In NVO3, we assume there's an NVA with the information. And here is talking about how do we distribute. Granted that you could have multiple NVAs. You can have one NVA responsible for VM 1 to 10,000, another NVA responsible for 10,001 to 20,000. That is all possible. So NVA as the
but it's still the slide 2, whatever, says how NVEs express interest in VMs.
Oh, because the NVE need to tell the NVA that the number of VM he's participating.
No,
So-
not if the NVA is God and knows everything.
No, we're not saying NVA is a God.
But I thought that's the centralized model. So
Yeah.
I'm confused how this fits in with architecture. I'm not saying it's broken. I'm just don't know how it fits in with a centralized model.
Okay, here's
right?
the thing. So NVA, we may have multiple instances of NVAs, right? NVA 1 responsible for 1 to 10,000, NVA 2 for the 10,000, 1 to 20,000. So that when NVE announced himself, I have VN 10, so it is the NVA 1 who will distribute the content to this NVE. The NVA 2 will not do anything. So the NVE himself knows which VN he's responsible for. So when he send the link state, broadcast to all the VNs, all the NVAs, here are the VNs I have, it triggers specific NVA to distribute the content to him.
Yeah,
For what it's worth, Eric, your question is exactly what I'm wondering. So I think we should have a discussion afterward to make sure we understand the same thing, and then we can have more discussion on the list.
Okay.
For the sake of time, let's just take one more question.
Yeah, just a question to understand the mechanism. When the NVE send a query to the NVA, the response sent to all the NVE or just only the query NVE?
And only the query, the requester.
So you're not using the ISS flooding mechanism. You're just sending
Reply, yeah, yes, correct. So
typical ISS always flooding, right? You never.
No, so this NVE is announcing the VNs he's participating. That is the broadcast, because he's not sure who has what information. So that's the link state. And for query, that's the unicast. Like when I do query, I know which NVA has the information. I can send a unicast message to that particular NVA.
So typical ISS always do flooding, right?
Okay, I'm talking about the push mechanism using link state.
This also ties back to the question that I have. So maybe we should talk afterward when we can spend a little more time and maybe draw a picture here.
Okay.
So
Thank
you. Next presentation is Yizhao. Let me get the.
Okay, this is Yizhao Li. I'm going to give a briefing on the existing working group document for the split NVE control plane protocol, and also touch a little bit on the solution space, which is a candidate protocol called VDP. Okay, this is a current split NVE structure. The split NVE is a particular type of NVE that has a functionality split across an end device, which supports the virtualization and an external network device. So actually, the control plane protocol running between the hypervisor and the external NVE is kind of the intra NVE protocol. Then we call the part located on the end device is called TNVE, T4 terminal. And the part running on the external NVE called NVE, and is for network. Here we use a hypervisor to loosely define the thing running on the end device. It can be possibly a container. So the control plane protocol is defined by the framework draft as an intra NVE protocol. And these slides give a brief introduction on the state transition of a VAP instance on an external NVE. So basically there are two things. One is the VN is connect to a particular VN, and another is to disconnect from a particular VN. And this diagram here gives possible state transition for a TSI instance on an external NVE. Basically trying to talk about there are two possible states. One is associated, another is activated. And the state transition can be triggered by various VM events like VM migration or VM creation and shutdown, possibly like the suspension. So there's a state transition between different states here. And next slide. Yeah. Oh, sorry. The previous slides are all the wrap up for the existing document, and here we're trying to compare it with the VDP structure defined by IEEE 802.1 QBG, because we think if we were talking about layer 2 case, actually the VDP is a good candidate to be used in this scenario. So look at the bottom part, the picture. Actually, this 802.1 QBG defined the EVB station and EVB bridge, which is kind of equivalent to our end device and external MVE. They defined the VDP, which is a VSI discovery and configuration protocol, to be running between the EVB station and the EVB bridge, and try to carry the virtual machine networking states between them. So there is also a draft which is written by some experts from who designed this QBG to give a gap analysis between the current VDP and some earlier version of the requirement document. So these are the one by one analysis for the requirements provided by the document. I'm not going to go to the details for all of them. Actually, the requirement 1 and 2 says it is possible there's some intermediate bridge in between of the end device and external MVE, and and requirement 3 and 4 talks about multi-homing MVE cases, and number 5 says about the VN connection and disconnection requirements. So the right-hand side column actually describes whether the VDP extension is required. We can see some of the extension is required and pretty straightforward, and some of them has already been supported by current VDP, like number 5, which is VN is indicated by group ID in VDP, and also there are some current VDP can send a deassociate from the bridge to the end device, which has already been supported. And here are the rest of the requirements. And what's it called? Talk about it's like. The state transition, because we define like the associated and activated states in current requirement draft, and the VDP has a pre-associated and associated with which like equivalent status. And here is something like, what's missing in the VDP? Because VDP originally was designed for the layer 2, but currently NVO3, we're trying to support both layer 2 and layer 3, so we can carry, we hope it can carry the IPv4 and IPv6 address in their association message. And also like we want the clear indication for the VM migration events for better further implementation. Anyway, so here it comes to the summary of the possible extensions. We require a specific unicast destination MAC address rather than a nearest customer bridge group multicast address. And also we need a TLV for integrity check. And we need another new filter info format type for the IP address binding, and also another clearer migration indicator, which can be designed as bits put into new filter info format. Also, we want to clarify the associated to pre-associate state transition. Current state machine in VDP actually allows it, but not intentionally, so we want to clarify it. And the status and the next steps. The status is this deck of slides actually has already been discussed in 802.1 plenary 2 weeks ago. And .1 has shown some preliminary intention to extend the VDP upon NVO3 request. So what we are going to do is we need to perform another round of draft editing, and we hope can send a liaison from NVO3 to 802.1 to request for the following thing. The first thing is to some amendments, and another is the extension based on the document based on the requirement document about the new filter info and the new TLB types. I think that's the last slide, right? Okay. Yeah, that's all.
Any questions? So I'll take the opportunity. I know I started a discussion on the mailing list, and the topic was whether we would, and again, the terminology, maybe I'm getting it wrong, maybe it's just confusing, or both. But the idea of this extension from the NNVE to the TNVE as a tagged, local link, whether that was an extension of the VAP or the VN. And Larry's, the latest email I saw on this was Larry's comment that actually the architecture says that policy is inter-VN, not intra-VN. And so there seems to be a relationship here, and that was, I think, Larry, you hit it on the nose, at least for what I was thinking about. It might be good to continue that conversation on the mailing list and see whether the architecture's correct in that assumption and whether that means that we can be more narrow in VDP, and I'm open to whatever. So.
Yeah, we're going to do that because it's like a couple of hours ago discussion, so we are going to have more discussion on it. But I want to highlight current 802.1 QBG can support two modes of operations, but probably is not within VDP protocol itself is something other like LLDP extensions. We need further investigation on this issue. Probably it's also related to the NVA control plane requirements rather than this one. So yeah, we will do that. Pat?
Yeah, I just wanted to clarify. So there's some interest in 802.1 in doing this if NVO3 wants it done. There is no interest in doing it. I mean, we're not pushing it, but it seems like it could be a good fit. And if NVO3 says, yes, this is the way we want to go, then I believe 802.1 will cooperate with that. Just
thank you. Yeah, so let me say, I believe that the working group consensus is that we would like VDP to fulfill this requirement. I haven't heard anybody object to that, and I've heard a number of people confirm it, and it makes sense to me. So in absence of any issues anyone can think of, what I think we should do is have a discussion about consensus on the mailing list just to confirm that, but then send a liaison referencing this draft and saying that eventually we would reevaluate, or rather we would evaluate VDP against those requirements when they let us know, or something like that. The details we can work out, but I think that's the process we would go through here.
Right.
So would that work?
That's what I'd like to see.
Okay.
And then I think once we decide to go that way, or decide we have consensus to go that way, there'll need to be some refining of exactly what all we need to put in the filter info format. I mean, I think we know some of what needs to go in there, but we'll need to work that out to some extent with guidance from NVO3 on exactly what fields and what variations, because we've got, right now we have 4 filter info formats that we define for layer 2 for different situations. It doesn't have to be one format, but some small number of variants of what kind of information we want.
Eric Nordmark, a clarifying question. So I was just looking through the gap analysis to see whether there were any multicast related gaps, and I didn't find the string multicast, which could mean that everything is fine and we don't need to worry about anything. But I was a bit worried when I saw, okay, we're passing a unicast MAC address. Well, how does multicast L2, L3? Is that just stuff that works? Because you're sort of associating your TS with effectively a VLAN or something, right? Some virtual network. And multicast just works, or does there have to be some special filtering added for multicast as well?
The discussion is still underway because originally the originally the VDP assumed there is a single hop between the end device and the MAE. So the multicast is not an issue anyway. But here in NVO3 context, actually we are assuming possibly there is an intermediate classic bridge. So in that case, we are just like I said a couple of hours ago, probably we need some refinement of some more investigation on this issue.
Yeah. So you were asking for multicast for the protocol about being multicast, or are you talking about multicast for the overlay being multicast? Okay.
Okay.
All right. Thank you. So, I think I'll look forward to some. I can take the mic from you. Oh, thank you. So I look forward to some discussion on the mailing list, and we can chat obviously offline. That was the last item in our agenda today. Like I said earlier, we have a session on Wednesday. Sorry, this is very small print probably for everybody, but this is the agenda, and it's online, and we're going to talk about some OAM stuff, and then we've got some time carved out to have an open discussion about the data plane adoption that's going on. If everyone's perfectly fine, we'll have a very short, nothing kind of discussion, but we have some time just in case. So everyone, thank you for coming, and I look forward to seeing most of you, hopefully all of you, on Wednesday.
Blue sheets.
Yeah, who has the blue sheets? And if anybody has not signed them, please don't leave the room until you do.
We have a candidate for NVO. Hi.
Hi.
Yeah, NVO3 data plane requirements. Editor.
Okay.
Because she's implementing it in our process.
Okay. Just drop me an email.
Yeah.